Okay, well, last time we had a relatively long lecture on Mecham, uh, setting up a humanoid character and how to make them walk and run and jump and do all the different things. Today I want to extend this to AIs, artificial intelligence, NPCs, whatever you want to call them. So let me get my slides up here. So we're going to use Mecham, and kind of the really great thing about Mecham is we can use exactly the same controllers for our AIs that we use for our characters. That we have idle, run, and jump states, and they're controlled by various parameters: speed, direction, and jump. And we'll just write controller scripts that define those parameters. And our character will perform what we want it to do as we go through our different AI, our different artificial behaviors. We're not really doing artificial intelligence. These aren't thinking creatures. These are maybe artificial behaviors, but I'm going to call them AIs. And the basic thing that any of our little creatures will know is where the player is, and as appropriate, they'll either approach or avoid them. They can either follow or flee, and of course attack. And we might also have some kind of random movement for when they're not targeting the player. So they won't just move to the player in a straight line. They'll do various stuff. This idle function later maybe will turn into an attack function. So let's talk about random movement first, or wandering. The first thing about building these AIs is we're not going to put their behavior in the update function. We're going to instead put it in a while loop in the start function that I'll make into a coroutine. I'll make the start function a coroutine by making its type enumerator instead of void. For this to work, we're going to be using the yield command. The yield command says release this function for either one frame or for a specified amount of time, or until the coroutine finishes. So with our wandering AI, we'll start with a bunch of exposed variables. I'm going to work with two circles, an outer distance and an inner distance, and you'll see the reason for them as we go along. I'm also going to have some parameters for the damping, both of the speed and the direction. So this will control how our parameters respond as we set them. In start, I'm going to, of course, cache my animator with a get component. I'm going to call a function reset direction that specifies a random point that we're going to go to. And I'm also going to have a timer, so I'll catch the start time. And then I enter this while true loop that each pass through the loop does a yield return start coroutine idle. So as a coroutine that is yielded, it's going to block at this point, because this is a coroutine, and it won't continue around the while loop until idle finishes. Reset direction, I'm going to use a random inside unit circle. So this returns a vector 2 that is just a random X and Y position inside a unit circle. And I'll catch the X and Y components of that vector 2, and I'll use that to set the target position to be X, 0, and Z. And then I'm going to move that from my animator's root position. When we're working with these animators, we have a lot of access to where they are, their root position. I believe there's a center of mass position too. But we also have their root rotation, how they're oriented, things like their angular velocity, how they're spinning, and their velocity, how they're moving. So the animator gives us a lot of information about what the character is doing. So I've set a target position with this random number generator. So now the idle function. Don't worry, I'm going to blow this up in a minute. But this is all there is to the idle function. It's a coroutine. I enumerator idle. I've got a little trap here to make sure that I have an animator. I should have an animator, but just a little trap here. First thing I'm gonna do is generate some random activity. You remember my character has the ability to jump and slide, although I think I replaced the slide with a dive. And we have the ability to change the target with reset direction. So I'm going to throw a random range. This is going to return a number between 0 and 499. And if that number ever comes up to be 20, I'm going to set the Boolean jump in my animator controller that's going to make my character jump. If the number ever comes up at 23, I'll have them dive. And if the number ever comes up at 20, I'll reset the direction. It's a 1 in 500 chance of any of those things happening. So with my wandering AI, with the orientation, we've got speed, which is going to move our character forward. And we have direction that turns them to the right or to the left. The speed and with our characters, we based on v squared plus h squared. But with our AIs, we don't really need to do that. We can just set the speed to be either 0 or 1. We've got that damping that'll slow how it goes to 0 or 1. The direction, as you recall, went from -1 for a left turn to +1 for a right turn. And so we're going to have to generate that. We'll use a little trigonometry here, or vector math actually. The dot product of two vectors gives me the cosine of the angle between them. So if I dot two vectors together and the dot product is positive, it means that we're facing our target. The two vectors are our vector that we're facing forward and the vector to our target. So if that angle is positive, we're going to have a positive dot product, and it'll be negative if we're facing away from our target. So we can get the amount that we need to turn from the cross product of two vectors, which gives us basically the sine of the angle between them. So if the cross product is positive, it means we're going to be turning to the right towards our target. And if it's negative, it means we're going to be turning to the left towards our target. We're taking a dot product. I should use the left hand because Unity is left-handed. Dotting the direction I'm facing with the direction of my target. We'll get a positive vector for a right-hand turn. If I'm dotting to the left, I'll get a negative vector that's for a left-hand turn. Unity is left-handed. Everybody else in the world is right-handed. So I'm going to test my distance to the target. If I'm not too close, I'll set speed and direction using this dot product. So as long as my distance is greater than this inner distance, remember I mentioned the circles, I'm going to set the speed to 1 with the damping time. I'm going to get my current direction as my animator's root rotation. That's his orientation. multiplied by the forward vector. Multiplying a rotation times a vector gives you the vector in that direction. My wanted direction is the vector between the target position and the animator's root position. I dot those two. If it's greater than 0, I'm facing it, so I form the cross product. Take only the y component of it. Y is plus. However, if the dot product is negative, I'm facing away. So I'm again going to do the cross product, but this time, since I'm facing away, I'm going to turn as fast as possible. So I use one of these fancy ones where if this is true, if the y component is greater than 0, I'll do a 1 for a right-hand turn. Otherwise, I'll do a -1 for a left-hand turn. I do need to clamp these to be in the range -1 to +1. Since I haven't normalized these vectors, and we're getting, we potentially have directions that would be outside the range -1 to +1. And then I just set that float on my animator controller with some direction damping time, and I'm ready to go on. If this is not true, after some idle time has passed, I can, if I have some idle time, I'll reset the direction. And otherwise, if I've reached the target, if back here my distance is less than the inner distance, that means I've reached my target, and I would reset the direction. And then a yield return null, which ends this coroutine. So it would then go back way back here. That coroutine would end, and it would go around the loop again. So let me show you the wandering AI here. There's my wandering AI. I have a little circle here that shows that inner circle. Oh, come on, maximize. Maximize, maximize, play. Sorry. And wander. So here's my little wandering AI. When he sets the direction, he's throwing that green circle out there somewhere. As soon as he's inside that circle has a radius of the inner circle. So he's wandering around, doing his thing, and periodically doing a dive or a jump as those random numbers come up. So very cool.